Okay. So remember, these lectures will be on YouTube also. If you missed something or missed a day or just want to go back over it because it was tricky, might need that when it gets harder later. All right, classify the polynomial as a monomial, binomial, trinomial, or none of these. So they want me to classify a polynomial. So do you know what they're talking about? 10x. We're talking about 10x. Anybody know that one already? Yeah, it's actually a monomial here because it's only one term. This is a monomial. Mon means one. If you had like 10x plus 3 or something, that would be a binomial, two terms. And if you had, 3x squared plus 10x plus 7, that'd be a trinomial, three terms, like that. So it's just the number of terms. Now, the key, though, it's not... Because you might look at the 10x and go, well, why isn't the 10x two things? I mean, there's a 10 and there's an x. Well, if it was like this, it would be two things. So tell me what the key is. Why is this two terms and this is only one term in the way we call it, and we call it that?
The plus symbol?
The plus symbol. Or minus would be the same thing. Yeah, if I put a minus in the middle, that would also be the same issue. Yeah, pluses and minuses in the middle are the separators. Yeah, they separate it into more than one term. That's the key issue. Pluses and minuses separate. So yeah, so with this one right here is a monomial because there's no separation, huh? The 10 and the x are just together, one term. Yeah.
Division symbols do not separate?
It's true. Multiplying and dividing, right? Just like there's really a times here, huh? Yeah, and if I put 10 over x, that would also be a monomial. Yeah. Well, technically it's not. Here, let me do it the other way. Like this, x over 10 would be. That would also be a monomial. Yeah, right. Multiplying and dividing don't. Yeah, remember how I said, well, I mean, I'll say a lot of things, but multiplying and dividing rules always go together. Adding, subtracting rules always go together. So adding, subtracting both separate. You're right on. Multiplying and dividing don't. So 10 times x or x over 10, either way, that's still just one term. They're not separated. They're one thing. But when you have pluses and minuses, those separate into more terms. All right.
So, would there be one?
Yes, if there is, I don't even know what the name is. I'm not going to quiz you on it or test you on it. Yeah. What is it? You have Google or something, you can probably type in, what is a four-term polynomial? Poly just means many. So all these are polynomials. Yeah, good point. I didn't even define that word, did I? Yeah, polynomial. Poly means many when it's in front of a word. So that means many terms. So all of these are polynomials. And, one term monomial, two terms binomial, three try. Four, I don't know. If you have Google, you could type in, what is a four-term polynomial called? And I'm sure there's some name. But we're not going to be testing it. We would just choose none of these because it's not a monomial, binomial, or trinomial on that, much as we need to know. Yeah?
You said we're going to be doing how many? Three
sections a day? Usually. 2 or 3, depending on how thick they are. Yeah, right here in the beginning, 3 usually. Things get harder later. We'll slow down a bit and do 2. Generally our plan. I'll get you a new calendar. I actually have a new calendar because the holiday thing that I wasn't aware of, which is good news and bad news. I mean, I love a holiday, but it messed up my planning. I've already got a new plan. I just haven't got it to you yet, so hopefully I'll photocopy it, get it tomorrow or Thursday at the latest. You'll have a copy of it. It hasn't changed a lot. Our test is still Thursday. That's the main thing. Our test is still Thursday.
When you do homework, if you run out of the 3 options that you have to answer the question,
Yeah.
and then you go back and do a new one,
Right.
so you lose some percentage?
No, it's full credit once you get it done.
Okay.
Yeah, so if you miss it, 100 times, but eventually get it right, it's full credit.
Okay.
Doesn't matter how many times on that. Yeah, so you can get 100% in your homework, right? If you put enough time in there and practice it, yeah. And when it comes to the tutor who's going to come in at 11, Roberto, you can go over to the tutoring center. That's where he'll be, and they have computers there too. So you can just go right in there and do your math Excel homework in the afternoon. It's kind of a good plan. It'll probably speed you through. That way, when you get stuck, he's right there. And just go, hey, Roberto, what's going on with number 7 here on my homework? The computers are right there. Get it done and be on your way. Might be a good plan. All right. All right. So first off, do you realize this thing is a big monomial. It's actually one term. Why? Why is, you could say, well, that's three things. You got a 13, an x, and a z, but it's just one term. Why is it one term? No separators, no pluses or minuses, huh? It's just all one thing. Pluses and minuses would separate, right? If they made it 13 plus x to the 6 plus z to the 5th, then we would say it's a trinomial, wouldn't we? But they didn't. So it's a monomial. Okay, we got that. That's why they're calling it a monomial. Oops. And now, what do they want me to do about it? Well, they're saying, what's the coefficient? Do you guys know what the coefficient is? What does that mean, coefficient?
The number?
It's the number. Exactly. It's fancy words for the number. It's the 13. You're exactly right. It's like co-pilot or something. It's the number with it. Co just means with, whenever it's on a word, huh? So just 13. Okay, now what are the variables?
The letters?
Yeah, they just want x and z. They just want you to list them first without their powers. Now the degree is... actually, I don't know what the degree is. It's either the highest power or the total of the two.
I think it's the total.
Is that what it is? Is total of 6 plus 5 is 11. So it's the total of the two powers there. 6 and 5 is 11. Wait, let me say that more clearly. But yeah, well, let me leave it there for now. Yeah, so that's 11. Is that good so far? That makes sense for that one? All right, so you guys got that down. If I move too fast, it'll be on YouTube, but I don't want to go too fast. Let's go back and answer that. So I'm on the video screen right here, so it's recording the thing, but let me go back to the main program. Okay, yeah, so first off, yeah, you're right on the money. Their first question is, express it in descending order. Like, descending means from highest to highest to lowest. Like, say, a staircase descends, right? You go down, so highest to lowest. So they want me to take the x plus 4x squared minus 8, and they want me to go, so descending order means highest degree to lowest degree. Now degree, so when they say degree, they really mean power. Highest power, highest power to lowest power. That's what degree really means, power. So they want me to rewrite that polynomial, that trinomial, right, 3 terms, from highest power to lowest. So how do you do it? So I'm going to reorder. Which guy is going to come first? We have these 3 terms. Which one's coming first? Yeah, the 4x squared's coming first. Now, when you rearrange terms in math, you always keep whatever the sign they have in front of them with them. That's their baby, so to speak, right? You don't leave your baby behind, right? At least you shouldn't. That wouldn't be a good plan. I remember when we had our 5th child. We have 5 children. I don't know if I said that. It's crazy, isn't it? Anyway, it's fun, but it's more than I ever thought I would have. Anyway, we have 5 children, and I remember when we had our 5th. By that time, I feel like I got this figured out. I know how this works. My wife and I brought her home from the hospital from having our 5th, right? We had the day in the hospital. Coming home, on the way home, we said, hey, let's stop and have lunch before we get home to the wildness of 5 children. So we stopped for lunch at the restaurant, jumped out of the car, started going into the restaurant. My wife looked at me and said, so should we bring Abby, or do you think we should just leave her in the van? I'm like, oh yeah, we got a new baby and she's in the van. My wife likes to kid me. But anyway, you should not forget your baby. So the sign that's in the front, that's theirs. That goes with them wherever they go, right? So this sign right here is on the 4x squared. So it stays with it in the front. Okay, so next term, which one comes next? Yeah, this one, the regular, because he's an understood invisible first power, really, huh? So he comes next. Now, what sign's in front of him? What's over here in front of him? Nothing, which means plus. Yeah, nothing means plus. Okay, and lastly comes the minus 8. That minus, that's his baby. That stays in front of him wherever he goes. Yeah, so that's what they want. Highest power to lowest, which is what they did. Okay, next question is the degree. They say, okay, what's the degree of that? Now, here's the trick. You might look at it and go, no, Mr. Herron, you said you got to add up the powers. Well, you've got to add up the powers on any one term. But when you have multiple terms, you just take the biggest of them. Does that make sense? So when there's several terms, like we have here, 3 terms, right? The degree, I should have said it this way, the degree is highest power. So what, among these 3 terms, which one has the highest power?
Square.
Yeah, 2 power. So the degree is 2. See the difference between that and the last question? Like if on the last question, let's go back here. See, they had x to the 6z. Why didn't I just take the highest there? Because that was not multiple terms. That was one term. So when they're right next to each other, they're one thing. You got to add them up. Does that make sense? When they're right next to each other, you total them. That was the last question. But whereas if it had been 13 plus x to the 6th plus c to the 5th, in that case, what would the degree be? If they had been 3 separate terms, a trinomial instead of all one term, then I would not have added them together. They're not together. They're separate. So what would I do for the degree in that case? Just take 6. Just the degree would just be the highest in that case. See the difference? So if they're separated, then don't put them together. Don't add them together. Just take the highest one. But if they're all, yeah, that says it. So they're all separate. We just take the highest. If they're together, you add them up. Good on that? Questions on that? Okay. All right, so let's take a look here. 5x plus 4x squared minus 7 minus, oh no, they're all different. We can't combine anything, can we? So anyway, so all right, so what's the first thing we're gonna do? Gonna reorder them, right? So go ahead and reorder them on your own paper there. Remember to take whatever's in front of them, that's their baby, so to speak, take it with them wherever they may go. So this guy goes in the front, followed by this guy, followed by this guy, followed by that guy. Is that good? Highest power to lowest.
Why is it 2x over 6? It's bigger than 4x.
Oh, yeah, good question. It's not the number in front, it's the power.
Okay.
Yeah, it's all about the power. Yeah, so this is the biggest power. So he goes first, and then this one is the second biggest. And notice I'm always taking the sign in front of them, with them wherever they go.
So we're not, we'll be combining.
If they were same powers, we would combine. Like if these were both x to the 6th, for example, then I would combine them. Yeah, you can only combine same powers. We call those like terms. And we'll get into that a little bit more, I think today even. But yeah, for this one, they're all different powers, so nothing combines. They just stay separate. So that's the first answer they want. Now, the second question is going to be, what's the degree of this thing?
6.
Yeah, it's just the 6, right? We don't add up any of those powers because they're all separated, huh? Makes sense? Yeah.
What makes 5x bigger than 7? Is it because of the minus sign?
Yeah, well, it's because this is x to the first power, and this one has no x at all.
Okay.
Yeah, it's always about the letter. And, you know, if you've got the letter, you're bigger than somebody that doesn't have the letter.
So if it didn't have an x, I mean, if it didn't have the 1, if it didn't have a power, would the 5 still go before it because it's a positive? would the 5 still go before the 7?
Oh, you mean if it was just a 5 and a 7, neither one of them had an x? They would just subtract to be -2. I would combine them in that case. Yeah, if they were both just plain numbers and neither one had an x, they would be like terms. And I would just combine them and they would make -2. But one of them does have an x and the other does not.
Okay.
So they stay separated and the x one comes first. So yeah, basically what we're doing is we're saying who's got the most x down to who's got the least x. Right? So this one has x to the 6th. He's got the most. He's got x to the 2nd. He's only got x to the 1st, and he's got no x at all. So he's last. So it's the most x down to the least x. That's what they're wanting us to do. Good. All right. All right. So they're giving us that polynomial. Let me write it over here. P of x equals 8x plus 5, and they're saying x is 6. So they want me, what they're saying, evaluate. Whenever they say that in a math expression, evaluate, they want the value. They want you to plug in the number. Evaluate, give me a value. So they want me to take that x equals 6 and plug it in to the x slot. It's kind of like putting bread in the holes of a toaster or something, right? You're just plugging it into the machine. Excuse me. Excuse me again. You can really just forget about that. You don't have to do anything with that p of x equals. You can just skip it. It's all just about the right side, the 8x plus 5. And do you remember, I don't know if you've seen before, when you plug into a formula, you always put parentheses around the number you're plugging into the formula. So I'm going to put parentheses around this 6, and I'm going to plug it in where the x is. Let me get that door for you. So, so right where that x is, so it'll become 8 parentheses 6 plus 5, and then I'm going to work that out. Does that make sense so far? So you just plug it in where the x was. You put the, like plug in something into a toaster or something. We just plug it into the x, and then 6 times 8, you can use your calculator for any of these things if you're rusty on them. 48 plus 5, 53, and that's the value. We worked out the value.
So for test reason, do we have to put it like that, or we can just do it our own way?
What do you mean, like what kind of?
I mean, because I can go straight from 8x plus 5 and just multiply times 8.
Yeah.
8 times
Oh, yeah.
8.
You're saying you just work it out in your head. You got it. That's totally fine. That's totally, yeah. Because on the test it'll be multiple choice, so I won't see your work. It'll just be, you'll just grab the 53 and you're good. Yep. Yeah. Good. All right. Good deal. All right. So here, I'll rewrite it here. PR equals 5r squared plus 7r minus 7. And they tell me r equals 5. So try that one. Again, you don't even need the left side. Who cares? It's just all about the right side. Everywhere you've got r, you're going to put parenthesis 5, boom, and boom, into both those.
Then the exponents would be outside or inside?
Yeah, outside. Good question. Yeah, outside. So, so it'll be like this. Does that make sense? And then just kind of work that out with your calculator or by hand, either way. So just plugging it into the toaster, so to speak. Plugging it into the R slot. You can use calculators on the test. Not cell phones, though.
It's not software?
Not cell phones. I mean, today's fine, but not on the test. Because you could, like, call out for answers and things. In fact, there's programs now you can just take a picture of the problem. It'll solve it.
Oh, yeah.
Yeah, my kids were telling me about that. I don't keep up with technology, but they're like, oh, no, Dad, you can't learn about something. You can just take pictures, and these programs can solve them instantaneously for you. So, yeah, we math teachers have to outlaw cell phones in all settings now. All right, so All right, so remember the order of operations? What do we do first there? That power, good job. Yeah, so first thing is that 5 to the second power. Yeah, remember that rule? So that'll be 25. Whoops, here, let me just do one thing at a time. I mean, you could do the multiplying too, but so good so far. So I just did that power. Powers are first. Remember the please excuse my dear Aunt Sally, the order of operations, parentheses and exponents, powers in other words, multiplying, dividing, adding, subtracting, that whole thing. Anyway, so we do the multiplying 5 times 25, 125. What's this, 35? Choose your calculator. One's at 160, 153? Thank you. 153. Is that good? Questions on that? Just got to be careful. Working that out. Yeah.
So, like you, in the beginning, you have, PR equals, the polynomial.
Right.
You always take the R out, or,
The left side? Yeah. Well, technically what it is, I don't want to confuse you by giving you too much math symbolism, but technically it's not removed. I just noticed it confuses students over the years, so I don't do it anymore. But technically, like if you click on the help button, for example, what they'll show is really the 5 is plugged in here as well. But you don't do anything with it. Technically, this comes all the way down with nothing else being done. And then that's how you would write the final answer. But this is all we really care about. So really, the left side doesn't vanish as much as you put in the 5 everywhere you've got R, even here. It just doesn't do anything on the left side. In fact, what it's doing is it's making a statement, really. It's saying P with 5 plugged in equals 153. That's what it's really saying. Technically, it's read P of 5 equals 153. See, P is a function. P is a machine, is what it is. Technically, a function's like a toaster or something, and we're really saying the P function with 5 plugged in is 153. But again, you don't have to do this on the exam. You'll just be looking for this answer. Is all that matters.
So in other words, it's saying that if P was 5, then this is the outcome.
Exactly.
If it's something else, then the outcome would be different.
Totally. You're thinking right. You're thinking exactly right. Yeah. For example, yeah, I like to make things a little more real. Sometimes it's helpful that way. It'd be like if I said toaster. That's always my function analogy, even all the way through calculus. I'm always talking about toaster. It's a good way to think about a function. Toaster with bread put in will equal toast. Meaning if you put in this, you get out that, right? But toaster with frozen, if you can read this now, I'm kind of running out of room here. Frozen waffle put in equals what? Toasted waffle. Right, so that's the idea. That's what we're saying with this P of whatever, F of whatever. That's what function notation really means. You really can you read that? It's all scribbled on everything. That was terrible. All right, so let me erase this now that we have the answer, 153. Yeah, so in other words, let me do that last again. So it's like saying toaster with frozen waffle put in equals toasted waffle, right? Meaning this is what you put in, this is what you get out, right, to the toaster. That's what it means when we say in the end, P of 5 equals, what was it, 153? We're saying when you put in 5, you get out 153 to the P machine. So when you put 5 into the P machine, you get out 153. Just like you said, if we put something else in, we would get something else out. To that, if we put in 10 or 3 or some other number, we would get out something different, right? Just like with a toaster, you put in frozen waffle, you get out toasted waffle, you put in bread, you get out toasted, on you go. So that's all you're really saying. It's function notation. It's machine. It's like a machine. Plug in, get out. That's what that really means. Yeah. But on the test, all you need is an answer on the right. You don't really have to write any of that stuff on the left. It's just notation. All right. Good. I'm glad you guys want to know. So there we go. So P of x equals 2x squared minus 2x plus 3. And we're supposed to plug in 6. So can you plug in 6 there? All you really have to do is the right side. So plug in the 6. And we always put parentheses around the number we're plugging in. All right, so what do I do first here?
Power.
That power, yeah. Remember the order of operations, got to do the power. So 6 squared is 36, right? And then, what's that, 72 minus 12 plus 3, is it 53? Oh, is it 63? Oh, yeah, you're right. 60, 63. There we go. Is that good? Getting that okay? Questions on that? See how that worked out? So do that power first, and then the multiplying and subtracting. Okay. You have a third power button, most calculators do. Or you could just multiply it 3 times by hand. Or by calculator, I mean. So V equals 4. Try that one, plug in a 4. So plug in the 4 with parentheses around it, right? Whenever we plug into a function, to a machine, plug in with parentheses. Oops, I put a V there. What did I do? It's supposed to be 4. So plug that in. Do the power first. So 4 to the third power, you know that means 4 times 4 times 4, which is what, 64? Like that. Good so far. So first I do that power thing, that third power, 4 times 4 times 4. Okay, and then, well, this is what, 128, 36, 10. I don't know, what's that?
Isn't that the first one, 256?
Oh, did I mess up? Oh, it's 256, not 128. I'm messing up. Yeah. 256, and that'll be 220, 210? 210 in the end. There we go. Good on that? Questions on that? All right. It's probably just a plug-in thing. A bunch of fancy words we can ignore, maybe. I don't know. Let's see. The distance s in feet traveled by a body falling freely from rest in t. It always sounds. That's how physics talks. They talk about a free-falling body. It always sounds like a human body. They don't mean that. They just mean any object falling. But that's just the way they talk in the physics world. By a body freely falling from rest in t seconds is approximated by the polynomial s equals 16t squared. We probably just need to plug into that thing. Probably the whole problem is just plug into that. A brick is dropped, yes, we're dropping a brick. A brick is dropped from a building and takes 2 seconds to hit the ground. How high is the building? Yeah, so it is that. So they're giving us this S equals 16t squared thing. And the trick usually in word problems is just being really clear what the letters are. So notice it says what t is right here. Do you see it in the words? What is t in? Seconds. So anywhere you see seconds, anywhere else in the problem, that means you can plug in for t, because t is seconds. See how you do that? That's really the main thing in word problems. Just identify what the letter is and then look for that number to put in. So where else do they say seconds? Yeah. So guess what that t, I just said it. That 2 is t, isn't it? Because it's seconds and t is seconds. So they're basically saying, hey, plug 2 in for t. That's all they're saying. It's a bunch of fancy talk for plug 2 in for t. You see how I came to that conclusion? Usually word problems are like that. If you can just identify, all you got to say is, what is t? Seconds. Oh, 2 seconds. So they're basically saying t is 2. Put it in. That's all they're saying. So can you work that out? Go ahead and put the parentheses around the 2 and, just work out the right side, just like the other problems we did. Just like that, right? Makes sense. That's what? Do the power first for 64? So that's a way, that building must have been 64 feet high. If it takes 2 seconds for the brick to fall, that's kind of interesting little physics formula. It's true. That's a true physics formula. Meaning if you plug in, if it takes a brick 2 seconds to fall, that means the building was 64 feet high. A brick will fall 64 feet in 2 seconds. And if you dropped a brick and it took 3 seconds to hit the ground, you could plug a 3 in, and that would tell you how tall that building is. That makes sense? So if you want to go off to next time you're staying in a hotel and you want to drop things off the balcony, right, and time how long it takes to hit the ground, you can calculate how high you are with this little formula. Just bring that formula with you, 16t squared, and you'll know how high you are from the place you dropped it, based on how long it took on your stopwatch for the object to hit the ground.
So 16 is a given?
Yeah, you know what that number comes from? It comes from the gravity constant. Earth is accelerating all objects at 32 feet per second squared. You do a fancy math thing, so it turns this 32 into a 16 because you divide by 2 for another reason. So that's where that 16, it has to do with the gravity pull. Like if I drop my pen, gravity's pulling on all objects, accelerating them at the same rate. That's what that's all about. Yeah. So yeah, that formula is true. So you could just remember that formula, and you could, if you know how long it took something to fall, plug in the time, and you can figure out how high that object was. Now, one mistake, one exception, that's aside from wind resistance. That's not counting the fact that wind could slow down or speed up an object. That's just the earth pulling on there. That's why they did a brick. Because a brick's not going to be affected by wind much. But if you drop a feather, yeah, it's not going to work because the wind is going to have a big effect on that feather. Right? So that's aside from wind resistance, that physics formula. All right. Let's see. The daily number of accidents involving drivers of age A is approximated by the following polynomial. Look at that polynomial. Evaluate the polynomial for A equals 45 to find the daily number of accidents involving 45-year-old drivers. It's like what insurance companies would use, right? So let's try that. So it's n equals 0.4 a squared minus 40a plus 1039. So what do they want me to do on this problem? Yeah. You can really skip all those words and just focus right in there, huh? They just want you to plug 45 in for A to both A slots. So plugs in right there and right there. Plug that in, parentheses around the 45, and use your calculator. Do the powers first. All right, so let's plug that in. 0.4, the A is 45. So that's going to be really big. Somebody got a final answer?
45, oh, the final one?
Yep.
49.
Oh, 49, just nice clean 49? Okay, you guys getting that in your calculators okay? All that works out to be 49, I guess. If you have trouble with that, feel free to come on up at the break. I'm glad, calculator stuff, it'll be 5-10 seconds. I can do that with you real quick and easy. And make sure you can do these. I'd encourage you to bring your calculators to class. Make sure you can work these out.
How much are they at the bookstore? Does anyone know?
What's up?
How much are they at the bookstore? I got one.
Calculators?
Walmart for $13.
Yeah, what'd you get?
I got a Texas Instruments.
Yeah, good deal, good deal. Yeah, if you're gonna buy a calculator, so that one's great. I'm sure. This one is fabulous, and I'm not normally into. It is nice, isn't it? Yeah. Yeah, it's super. Casio. So you don't get it if you've already got one. It's not worth all that. Yeah, but if you're gonna buy one, it's the same price as all the others, and it's off the charts. I mean, I could do a commercial for these guys. I feel like I'm really impressed. I am. The Casio Natural Display.
How much is it?
It's like the same price as any other. I think $13, $14. It's not. It's not. Oh, it's Walmart, Target, bookstore. It's the same price as all the rest, but it is superior. As far as it's just really easy to use. That natural display means you type it in just like it looks. You don't have to do anything fancy, and it just calculates it. It does fractions automatically. You can convert fractions, decimals back and forth. Does all that very, very conveniently. It's super, super nice. Casio Natural. Don't get it if you already got one, but yeah, if you're going to buy one, that's a really nice one. We own 3 of them in our house. They are easy to use. All right. So combine like terms. You've probably done this before. So 3x plus 3y plus minus 4x plus 7y. And all they're saying is add. In other words, I'm not plugging any numbers in here. Notice they're not giving me like a value to plug in for x or y or anything like that. We've stopped doing that. We're done with that. Now what we want to do is just combine the like terms together. Let me write that out. So combine like terms, meaning x's with x's, y's with y's. So, and the parentheses, they're not doing anything. You could just drop them. The parentheses are not doing anything because they're not right up against each other, huh? Remember, if the parentheses are right up against the walls of each other, then it would be multiplied, wouldn't it? But if there's a symbol in the middle, like there's a plus in the middle, then they're really doing nothing. Skip them. Yeah?
You're not inverting, you're not changing them to the opposite symbols for the second binomial?
To the opposite?
Yeah, you're not changing pluses to minuses and minuses to positives?
No. Oh, that would be if there was a minus in the middle. I see what you're saying. Yeah, if right here in the middle was a minus, then I would have to distribute, and that would change the signs. Yeah, so if there's a minus, and I'm sure they're going to give me one of those in just a second. So it's good.
That's the next one,
Is that the very next one? Yeah, so that's what we'll do in just very next problem. When there's a minus in front, then you've got to change the signs, yeah. But for the plus, we don't have to mess with that. So we just say, all right, just 3x and minus, just going to combine this. So 3x minus 4x minus 1x, is that good? 3 minus 4 is negative 1x. And then 3y plus 7y, 10y. And we're done. That's all they want.
Would it work the same way if you just write it minus x plus 10 y?
Totally, you're right. Yeah, because that 1 is understood to be there. The 1's invisible if you want. Yeah, we can always. You don't have to show the 1. Right. Either way, both those answers are good. Yeah, and on the multiple choice test Thursday, grab either one. Right. If you have either option, they're both right. Right. I'm not saying they would put both. They won't put both. But like if you have this one on your paper and option C is that one, grab it. It's the same thing, right? That's the same answer. Good on that, so combine and all right. So 3x minus 6 minus 5x plus 4. All right, so now there's a minus in the middle. Now remember, whose baby is that? Remember my whole I almost forgot my 5th baby in the car 10 years ago. So my point is, it's his baby, right? Signs go with who they're in front of. It's not, this minus is not going back in any way, shape, or form. It doesn't belong to the one behind it. So I want to make sure, first off, are we clear on that, right? Any pluses or minuses, they belong to who they're in front of, whether that's a parenthesis or a letter or number or whatever, that's their baby, right? So, okay, so that minus belongs to the parenthesis it's in front of the second parenthesis. And what is it going to do? Well, really, it's a minus 1. Whoops, that's supposed to be 1 there. It's a minus 1. You don't have to you just leave it a minus, minus 1, same thing, whatever. And it's going to multiply both of the ones in the parentheses. Now, why is it going to multiply? Because it's right up against it. Remember, anything right up against the wall is a multiplication. That's a minus 1 right up against the parenthesis wall. So it's going to be minus 1 times minus 5. What happens when we multiply two negatives? Yeah, we saw the reason why yesterday, right? Two negatives multiply to be positive 5x, huh?
Well, why did you put the 1 there?
You don't have to put the 1. If it bugs you, you could just say, look, it's just a minus sign up against the wall. And what is minus times minus plus? Yeah, so either way, I'm just putting a 1 because sometimes people like to see a number. You don't have to. It's just a minus sign if you want. And so what? Yeah, let me stop and pause and say what I'm really doing so it makes more sense. A lot of times we stick 1s in places just because it's helpful. You can do that as long as it doesn't change any meaning. Does that make sense? All the time we make things look different if it doesn't change the meaning and it's helpful or easier. But I can't put it like a minus 3, for example. That would be like totally different, right? But 1 times anything doesn't change, right? If I go 7, I got a number 7. Is that different than 1 times 7? By putting a 1 in front, did I change it? No. So I could put a bunch of 1s in front, and I haven't changed the value. So if that helps me somehow, then great, go ahead and do it, because it's still just 7, isn't it? That's the kind of thing we're always doing in math. I think if I say it out loud, it might make more sense. We're actually doing things that are convenient, but they can't change the value, right? That's what we're doing all the time. So that's why we do the 1s all the time. They don't change values. All right, but yeah, you can just do a minus sign. That's fine. Minus times minus is plus, and minus times plus is minus. Remember when 2 minuses get together, they make plus, but 1 minus times a plus is just minus. Remember that? We saw proof of that yesterday, right? We did patterns, remember all that? All right. Now, what's in front of this parenthesis? What's his baby?
Positive 1.
Yeah, just positive 1 if you want, or just plus sign. He's going to distribute as well, but he doesn't change anything. So he just comes on down. By the way, I lowered the walls. The floodgates came down, the water went in. Right? You with me? I want to be clear, because people ask me a lot, it's a good question. How do you know when these parentheses come off? Well, that's the whole thing. When the walls come down, whatever's waiting in the front, right? We're going to have that finally this summer, right? We have water now in the dams. They're full of water. So when the walls come down, the water will go, right? That's exactly what we're doing. So I dropped this set of parentheses, and the plus sign went in. But plus signs don't change anybody. So nothing happened because he just had a plus sign, right? Positive times 3 is still just 3. Positive times negative is still just negative. Nothing changes when a plus sign hits it. But the minus, when these walls came down, a minus sign was waiting outside, and minus changed both signs, didn't it? Everybody see that? Minus signs, when they hit things, the minus times minus becomes plus, and minus times plus becomes minus. It changes signs. Yeah?
Did they actually want us to do that one, or did they want us to write that right there?
No, oh, yeah, no, they want one more step. Yeah, I'm like halfway through. Is that what you mean? You're right. One more step. Now, combine these two. Got to combine like terms, right? We always put x's with x's, numbers with numbers. So 3x and 5x. Doesn't matter that they're separated. We go ahead and... Oh, they're using b up there, aren't they?
Yeah.
Oh, is that bugging you? Sorry. I should say I don't like using b because my b's look like sixes. Yeah. So I'm just going to use x, and in the end I'll type in the answer with b, but it's the same thing. Question?
So, before you went to the next step, basically all you're doing is just figuring out what the multiplication is doing to the other numbers?
Yeah, exactly. Yeah, I'm letting the signs in the front. There was a minus sign in front of the second parenthesis, nothing in front of the first, which means plus, and I'm letting those signs distribute through the parenthesis. Whenever a sign or a number or anything is up against the floodgate wall, up against the parenthesis, when the walls drop down, then that thing is going to rush through and hit them both. That's all I'm doing in the first step. And minus signs change all the signs, right? Minus became plus, plus became minus, because that minus hit them both. They both got wet, so to speak. The water rushed in and it hit everything. And there, and here the plus sign rushed in, but no, that didn't change anything on that. Question? Yeah.
I know it changed into a positive, so what would you do? Would you subtract 3x minus 5x, or?
Oh, it's plus now. So now, okay, what's in front of the 3x? What's his baby?
Yeah.
Positive, right?
So it would, that negative wouldn't even, okay.
Yeah, this minus and this minus together have made plus. So they're not minus anymore. And so now it's just plus 3x and plus 5x, which is just 8x. That good? Just like terms, x's with x's. And now minus 6 and minus 4. Yeah, if you lose $6 and lose $4, you lost $10. There's our final answer. Does that make sense? Other questions? So anything up against the wall is like water up against the floodgate. When the wall comes down, the water's going to rush in and hit everything. Not just the front thing, huh? The water's going to hit everything inside there. So that minus sign, waiting up against this wall, hit this guy and this guy, changing both those signs. Whereas the other floodgate just had a plus, that hit them both, but pluses don't change anybody. So nothing. So really nothing happened on these first two. On that. And then we just combine like terms. All right, let's try another one. Sign change, that negative hit the negative to be positive, and the negative hit the positive to become negative. Yeah, changes them both. All right, there's a big one. That is a big one. All right, here. Oh, and it's S and P. I don't like S and P. I'm going to make it X and Y. So we got 3x squared plus 12x minus 5xy minus 9 plus minus 12x squared minus 8x plus 2xy plus 5. All right, so I made it x and y instead of s and p. Now, are any, what's in the middle between these two? Plus. So, are any signs going to be changed on this one?
No.
No. So don't even bother. You don't even have to do the next step because no signs are going to change. You only have to worry about the signs changing when you have the minus in the middle, huh? So I would just combine like terms right now. Nobody's signs are going to change at all. So just go ahead and, in other words, just drop the floodgate right now. Who cares? It's doing nothing, right? Because there's nothing in front of the floodgate but plus signs. And pluses change nobody. Does that make sense how I'm just ignoring the floodgates? If there was a minus in front of one of those parentheses, then I would need to change all the signs inside. But there's not. So I just ignore it. Now just combine like terms.
For 3x squared and negative 12x squared, would you keep the powers, the 2? Or
Yeah.
would you add them?
No, good question. We only add powers when we multiply terms, which we're going to do, I don't know, maybe tomorrow. But yeah, for now, powers remain the same. Just add the numbers or subtract the numbers in the front. Don't mess with powers at all for now, because we're not multiplying, we're adding and subtracting. Yeah, so go ahead and go from there. Combine like terms, just do the numbers in the front. So 3x squared minus 12x squared. Minus 9x squared. Good so far. So I didn't change power at all, just did the numbers in the front. Now,
Where are you getting the 9x squared?
3 minus 12 is minus 9. That makes sense what I did there? Everybody good? So I just took that 3 and that minus 12. Got minus 9 on that. The next one, we've got 12x minus 8x. So 12 minus 8?
Plus 4x.
Plus positive 4x. Good. Yeah, you don't want to write, like sometimes I see the mistake, people will just go, well, I'm just going to go 4x without any sign. That's not right. If you just write a 4x right next to it, that actually means times. If you put no symbol in there, that means 9x squared times 4x. That's not right. These guys were never timesing each other, were they? They were always plussing and minusing each other. You can't change it to suddenly be times like that. You have to just keep a plus or a minus. It's plus because of 12x minus 8x. All right, next one. Minus 5xy plus 2xy.
Minus negative 3xy.
Yeah, minus 3xy. Is everybody good with that? That was minus 5 plus 2 is minus 3xy. They both added xy, xy, xy. Right, see what happened there? Minus 5 plus 2 made minus 3. If you lose $5 and gain 2 back, you're down 3. And finally, minus 9 and plus 5? Minus 4. And there we go. Yeah.
I don't know if it's off topic, but is that in descending order?
Oh, good question. Yeah, it's a little debatable, huh? Because of the x and the y, like what's this power degree, what's that degree? Yeah, they're not making us do descending order on this one, so we don't have to worry about that.
But if we were the XY would go before the 4x, wouldn't it? Or no?
Yeah.
I don't even know officially. It's not important. What is important, what will become important later, is that you do highest power of one letter. They'll just really have you focus on one letter at a time. So notice they would just say go from highest x to lowest x. Don't worry about the y, for example, is what they would usually do. So this would be a fine order, yeah, in those cases. Good on that, on the combining of the like terms? Okay, so again, now why did no signs change there?
Because it was positive.
Positive in the middle, huh? It's only when you have minus in the middle that the signs on the right and the second parenthesis will change. All right. And subtract from and all that kind of stuff. Okay. Subtract minus 4x squared plus 6x minus 4 from 6x squared plus 4x plus 1. Subtract from. When they say the words subtract, this from this, yeah, what is that? What do those English words mean we need to do?
You turn it into swap the terms.
Yeah, the order needs to swap. Like what if they said subtract 3 from 5? We know the 5 would come first and the 3 would come in the back, huh? Somebody just says, hey, subtract 3 from 5. That means the 3 goes in the back, doesn't it? So same way, when they say some big old fancy polynomial, it's still the same truth. That has to go in the back and this guy in the front. So it's 6x squared plus 4x plus 1. And let's put parentheses around both of them. Let me erase this other stuff.
How do we know to put parentheses around that?
Yeah, I'll explain in just a second. Like that, yeah. So, yeah, you do have to put parentheses around them. Here's why. According to what they're saying subtract this guy, right? The minus 4x squared plus 6x minus 4. Subtract that whole thing from the other one. If I don't put the parentheses, if I do not put parentheses, then I'm technically only subtract. If I don't put parentheses, then this minus sign, this subtraction symbol, is going to hit only the minus 4x squared. And it'll make it plus. But it won't touch the 6x or the minus 4. They'll stay as they were, and that's wrong. Why? Because I was supposed to subtract this whole thing. They said subtract the whole thing, not just the front part. See the difference? If you don't put parentheses, you're not technically doing what they said. They said subtract the entire polynomial, not just subtract the front part only. So you've got to put parentheses, and then you know what a minus in the middle does. It's going to actually distribute, isn't it? That minus is going to go boom, boom, and boom, and you'll subtract the whole second parenthesis, changing all the signs. Yeah, that's the only way to be faithful to the words. Subtract the whole polynomial. So go ahead and do that. Do what we did before. The first polynomial, the first parenthesis doesn't have anything in the front. So just drop them. The parentheses on the first one don't really even matter. But the parentheses on the back one matter. The minus sign distributes. I guess you could skip them and just change all the signs yourself right away. That'd be fine too. Is that making sense? So we'll get plus, minus, and plus. And the first one, no change. They just drop down. Like that. Is that making sense? Everybody see what we did there? So again, the minus in the middle, this minus in the middle that came from the word subtract, changed all the signs on the right. Questions I can answer? Yeah, so I'm just writing down the two polynomials, and I'm switching the order on these guys. Putting this guy at the back and this guy at the front, and putting a minus in the middle because they said subtract. So whenever they say subtract from, that means switch the order. If they said find the difference between, I would keep the order the same, wouldn't I? Remember those yesterday? Difference between versus subtract from. It's an English thing really more than it's a math thing. The English words subtract from mean you have to switch the order. And put a minus in the middle. And you remember when there's a minus in front of a parenthesis, it changes, all these signs change, notice. Right? The minus 4x squared became plus. The plus 6x became minus. The minus 4 became plus. All changed. And now, combine, let me get these out of the way here. Combine like terms. So 6x squared plus 4x squared.
So this,
10x squared. Question?
so the subtraction doesn't affect the first parentheses?
Right, exactly. Remember, because that's not his baby. It's whoever it's in front of. This, yeah, real good question. This minus is only in front of the second parenthesis. It's behind the first parenthesis. So signs never work backwards. They only work to the thing they're in front of. Good question. Is everybody good with that? Yeah.
Would the -4 become a +4?
Yeah.
If
Yeah, so if this was originally a positive 4,
That would become a negative.
then it would become a negative. Exactly right. It's just gonna switch whatever sign's there. Yeah, minus in front of a second parenthesis changes all the signs in that second parenthesis. That's what it does. See how they all three change. So, combining like terms, you got 10x squared, and then next we do the what? The 4x and the minus 6x? Minus 2x. Exactly. Good there. And the plus 1 and the plus 4? Plus 5, and we're done there. Does that make sense? Questions on that one? Good. All right. Okay. So try that one. That'd be a good one to practice. Give a little more extended time. I'll wander about. Let me know if I can help. Give a little more extended time. Feel free to check with those around you too during lecture. And you can bring laptops and cell phones and get some of your homework done if you want. I don't know if I can help in any way. Yeah. Gotcha, yeah. Let me see, let me watch yours. Okay, so just let me know what you want. That's built at 21 or something like that. And then lay out what you got there. Yeah, actually, go ahead and write these words out. Write out what you got there. And the word subtract too. So, yeah. Yeah, excellent. Oh, wait, we did, I think you forgot the word from. No, we didn't. There. Remember, first up in the whenever you have the word subtract from, you have to swap out to take this whole thing right in front.
So what did you get?
All three of them, just right in front.
Because 7 minus 7 is 0, right?
Great. And then this whole thing right there. And a big minus, no, big minus, the from is minus, and a parenthesis. That's the second one. Yeah.
Right.
Minus the first.
Right. Yeah, perfect.
So then
Yeah.
this plus, this not plus?
No, just keep, just go to like the rest.
This
Let's
makes
take it down.
Mhm.
Bring it down.
This, and then,
Yeah.
this makes sense.
Yeah, perfect, perfect. And is that good so far?
Oh, yeah, minus 14.
So yeah, whenever it's
Yeah,
subtract from, they
yeah.
flip, and you put parentheses on that, and what's that minus sign gonna do?
$7 and $7.
Boom. And so change all the signs.
Plus 10. Right?
Yeah. Perfect.
Yeah.
Yeah.
Because you have
What's
minus,
that?
plus minus.
Well, cause what sign's on the seven?
Negative 3 minus 7.
Yeah, cause that's positive, perfect, yeah, you got it. And then minus.
No, because you multiply two minus, and turn it, into
Yeah, it's
plus.
gonna change, so change that.
So it's plus 3 plus 7.
Yeah. Excellent. And what we'll do with that plus? Yeah. Yeah, perfect. And then this one, no change, because there's no minus in front of parentheses or anything like that. So bring down these three with no changes at all. Excellent, excellent. Now, this is my right turn. You expect those two.
Yeah.
Well, actually, we want to start with this guy. This guy there in the front. Do those two first. We're not multiplying, we're just adding. Minus 4 and minus 7. Yeah.
Or wouldn't we have?
You're right, yeah, it's good. We're just doing minus 4 and minus 7 to make minus 11.
Oh,
On that?
oh, it's before, I think this is, I thought it was before the six.
Oh, they need to swap over. This guy needs to go front, this guy needs to move back. So everything else is great, just, sorry, that first step, you gotta start over again with the first step. Yeah, remember, these have to swap order, right? When it says subtract from.
So let's subtract from on this one. So yeah, so whenever it says subtract from, this guy has to go in the back, this guy has to go in the front. Remember, that's the meaning of those English words, subtract from. So let me give you another second. If you did, it looks like, so minus 7v squared plus 3v plus 7, subtract
Yeah, remember that
7v squared
question that I
plus
had?
6v minus 3.
I figured that.
Is that good? See how I swapped order? Maybe I should draw these a little more clearly. So this guy goes in the front, this guy goes in the back like that. Is that good? Everybody see what I did there? Swap in that order like that. So that's what the words subtract from mean. They mean you gotta change that order. Good to there. Now what do we do? What do we do when we have a minus in the middle? Has to be distributed, yeah. And which signs is it going to change? All the ones on the right in the second parenthesis, huh? Because that's who he belongs to. He's their baby, right? This minus is going to go boom, boom, and boom. It's going to hit those three. That good? So that'll become, now what's the sign right here on the 7 right now? There's nothing, which means plus, so it'll become minus. What's the sign on the 6? Plus, it'll become minus. What's the sign on the 3? Minus, it's going to become plus. See how that worked? See how all three of those signs just changed? Now, is there any baby, so to speak, in front of the first parenthesis? Nothing. So just drop, just bring it down. No sign changing on that one because there's not a minus in front of that parenthesis. Is that good? In front. You might say, well, there's a minus right here. Right, but that's not in front. That's not in front of the parenthesis. It's only a minus in front of the parenthesis that changes all the signs inside, huh? Good on that? Everybody see that? And then, so now all the parentheses are gone. The floodgates are down. The water has went in, right? Everything's wet at this point now. Combine like terms. So this guy and this guy will combine. So they're going to, if you lose $7 and lose $7, -7 and -7, you've lost $14, huh? And 3V minus 6V? Yeah, if you gain 3, it's a +3, gain $3, but then lose $6, you're down $3, huh? Good, and then +7 plus 3, +10. And there it is. Is that good? How many got that? How good was that? Okay, good. A lot of you got that. Glad to see that. Questions I can answer on that one?
Do we only flip it when we're doing subtraction?
Subtract from. Yeah. Yeah.
That's
So,
how we flip.
not all subtraction though. Remember, they can use the word, remember from yesterday? Sometimes it's a good question, right? It's not all subtractions. Yesterday there was some, what are the other words? Not, they said say, different, isn't it? They would say, find the difference.
Yeah.
That keeps this, that's subtraction, but it doesn't flip it.
Oh, okay.
Yeah, so you want to keep straight. If they say, take the difference, let me write that out. If they say, take the difference, then do not flip the order. Whereas if they say, subtract from, you have to flip the order. It's just a matter of what those English words mean. It's an English thing. Yeah.
So in this case, instead of -7 b squared, if you had it backwards,
Right.
7 b squared, what will be the result? How do you write it down? The result you have.
If it was the other order?
No, instead of minus, it will be 7 positive b squared minus 7b squared. What will be the? How do you write it?
The v squareds would cancel.
So it's 0.
Gone. Yep. That's right. The other order we cancel. All right. Let's see. All right. Try that one. That's a sum problem. Give that a try. Give you a second on that. How are we doing? Now, what in this one does it say subtract?
No.
It says sum. And so what does that mean, sum? Add them up, huh? So 2x minus 5 plus, and there's nothing that there's no order switching because it doesn't say subtract from. So we're not swapping the order. Oh, did I miss something up? Oh yeah, thanks. There it is. All right, so like that, good so far? So it's a sum, huh? Sum means adding, not subtracting. Yeah. So, am I going to change any signs? No, because there's not a minus in the middle. right? There's only a plus. That makes sense. I mean, you could say, well, yeah, but that plus sign is the baby for the second one. Yeah, okay, right. And the plus sign will distribute. Okay, sure, but plus signs don't change anybody. So yeah, if you wanted, you could distribute it, but nothing would happen, right? Because plus times 9x would still just be 9x, and plus times 9 would still just be plus 9, huh? That's why we don't do anything with pluses, because they don't change anybody. Does that make sense? Only the minuses in the middle change it. So you don't need to do anything. All right, so then what do? Just combine like terms. All we don't need to change signs, but we do need to combine like terms. 2x and 9x. 11x. Minus 5 and plus 9. Plus 4, and we're done. Now, if you lose $5 and you gain 9, you gained 4. Is that good? Is that making sense on that? So I hope as we're going, I hope that your notes, you want to take good organized notes. That is, a lot of making it through math and science classes is organization and discipline and time management. It's a lot of those kind of things. So make sure you write down, hope on your notes right now, it says number 22 in section 1.8, and you have all that written down, right? And you kind of keep them organized section by section. That's always, you want to keep all that so you can look back and study that stuff. And when you get to the homework tonight, if you have trouble, if you're on 1.8 number 22, the one that'll give you different numbers and you get stuck, you can look back at this thing. It's your notes. Of course, you go to the YouTube too, right? Either one, and get the help you need, right? That's the plan on that. We have 10 minutes for our break. Let's start. We'll just start the next section. More challenging. So, all right. So what's the rule for that minus 7 and that 3? How do I know whether I'm supposed to add those numbers or multiply those numbers?
When it's up against the parentheses?
Yeah, that's exactly it. Now, when it's right up against the wall with no symbol, in fact, maybe it'd be helpful. Let's do two problems at the same time. Here will be A, here will be B. See the difference then between, whoops, that's not what I meant to do. I meant to do this. So let me do this. Look at the difference between A and B. A, what's in the middle between the minus 7 and the 3? Nothing. The minus 7 is right up against the 3, huh? So what does that mean? It's multiply. Right? It's going to multiply. So, and what's the rule with the signs? With negatives and positives and all that when they multiply?
Positive is a negative is a negative.
Yeah. 2 negatives makes positive. 1 negative's just negative, right? So when you're multiplying, let me write that down. Multiplying 2 negatives is positive. 1 negative is just negative, huh? Why? Why is that? Why did 2 negatives make a positive? I hope I'm testing if I made any sense to anybody yesterday. Why did 2? So somebody asked you, why did all these rules in math? Why did 2 negatives make a positive?
Logical thinking.
It's true. Right? Remember who's on the throne of math is truth. Not my opinion, not some math book's opinion. Right? Remember I did the little example with you, right? Remember? I did 10 minus 3, 10 minus 2, 10 minus 1, 10 minus 0. And we saw logically it had to be the case, right? Remember the answer? 7, 8, 9, 10 minus 0 is 10. And then from there, we just followed the pattern. So it's 10 minus 3, 2, 1, 0. What's next? Minus 1. And what's the pattern in the answer? 7, 8, 9, 10?
11.
It's got to be 11. So what did those 2 negatives just do? They added. See, it's just logical. It's got to be. It's not anybody's opinion. It's the truth, right? Math is just following the truth, which is what I love about math, right? English can be challenging for me. Oh, it's super important. Don't hear me wrong. You should do a good job at English. Probably more important than math. You learn to read and write well. Very important. But nevertheless, it was always a little frustrating. I always got B's in I could never get A's in my English class. I'd always get the paper back, and it would say 87 or 85. And I'd always go, why? Show me the 13 points I missed. Well, it's not like that in English, right? It's a little more subjective. The teacher's just I feel that's a B, right? I'm tell me why. On your exam, I'll tell you exactly why you got them right or got them wrong, and there's exact calculation, right? It'll have nothing to do with my opinion, right, or your opinion. It'll have to do with truth.
Can you do that same thing there with multiplication instead of subtracting? Does that make sense?
Well, yeah, what I'm showing is that these guys are actually multiplied. The subtraction is causing a multiplication. How do we know? Well, how did 10 become 11? This must have been made into a plus 1. These two minuses must have multiplied, and the two minuses must make a positive.
Okay.
Yeah, that's showing that must be what happened. How else did we get 11, right? Follow the pattern. It's got to be 11. And so what did these two minuses do? They made plus, didn't they? That's the truth.
Is that because on the outside of that -1 bracket, there is a -1?
Yeah, two negatives or -1, another -1 if you want. You can always stick a 1 in. Invisible ones are everywhere. They're everywhere. Yeah, it's true. You're right. Two minuses made a plus, or two minus ones made a plus 1. Exactly. Either way you want to think about it. All right, so with that in mind, that's the why. It's just following the truth. It's all it's doing. So two negatives do make a positive. One negative is just negative. That is multiplying. Even though I showed it by subtraction, those two on the right were multiplying. That's what they were actually doing. All right, so I'm going to multiply these two guys, and the answer is going to be negative because there's only one negative sign, huh? And 3 times 7, 21, so negative 21 there. Good. Now what about this one? Is this one, the part B, is part B multiplying? Yeah, it's not. Even though there's parentheses. Now sometimes people say, well, if there's parentheses, it's always multiplied, but that's not true. This is not multiplied, because why? Because there's a symbol in the middle, huh? That -7 is not right up against the wall. So it's not multiply, it's add, subtract. It's adding, subtracting. So it's like, so how do you do that? Do you go, if you lose, it's gains and losses, huh? If you lose $7 and you gain $3, you show anybody the 99-cent thing?
Yes.
Yeah.
Did you?
Yes, I think I budgeted though.
Uh-oh.
It took a while explaining to get it.
Okay. All right. So if you lose $7 and you gain $3, what happened to your bank account?
-4.
You're down 4. So everybody good on the difference between the multiplying and the adding subtracting? What's in the middle is what matters, huh? All right. Okay, so try that one. All right, so two negatives multiply to be, and it's positive or regular. You don't even need to show the plus. It just means plus without anything, huh? Regular 42 or plus 42. Two negatives make a positive when they multiply because Mr. Heron says so. No, that's not a good reason because it's true. I'm not on the throne. Truth is on the throne, right? Oops. There it is. You know what I would do with decimals?
Calculator.
Yeah, exactly. Just use your calculator. It's just, I mean, you can do it by hand if you want to, but it's just a big mess. Why? I think that's what technology is made for, right? Is doing the mess.
If you had to do it by hand, it would make more sense to rewrite them.
Vertical, total. Yeah, I would totally, not try to do it sideways by hand, yeah. So two negatives. I would do the sign myself, though. I wouldn't enter negatives in my calculator. I would just look and go, two negatives? Positive. So I know the answer is going to be, so I'm not even going to put negatives into my calculator. I would just type into my calculator regular 2.9 times regular 1.4. I know the sign of the answer is positive. Two negatives is positive, right? So I would just type into my calculator that, hit the buttons. What do you all get? 4.06? And it's going to be positive, so there it is.
Is that a multiplication sign? That X?
Oh yeah, I did the multiplication sign. Yeah, you don't have to.
Got it, okay.
They just showed it with parentheses, but yeah,
Okay.
either way. Is that good? Does that make sense? Shall we take our break? Right, we'll take our 10-minute break. Right there.